This video tutorial is going to cover Bohr models. This is a model of the atom that was created by Niels Bohr when he realized that electrons exist on energy levels surrounding the nucleus. So here we have two examples of a Bohr model. Now essentially what a Bohr model is, we've covered the basics of the atom. We have our nucleus in the center. Now with the nucleus, we always want to label inside the nucleus how many protons are in that atom and how many neutrons are in that atom. So remember, we can solve for that. Got the reminder right here. The number of protons determines which element it is. We can determine the number of protons from the atomic number on the periodic table. So if I see 17 protons, then I know that's going to be chlorine. And then 35 neutrons, I match that to chlorine's mass number. That's how I'm going to get the number of protons and neutrons. And then remember the number of electrons, what we're putting out here on our energy levels, that for the time being is going to be the same as the number of protons. So here we have chlorine. If we have 17 protons, then we are going to have to place 17 electrons on our energy levels surrounding our nucleus. Now, like I said, this is a model of the atom, and what Bohr models is going to show us is how many electrons are found on each energy level of an atom, and then how many energy levels go with each atom. So first things first, the number of energy levels. So the number of energy levels that you will draw with a Bohr model depends upon the row in the periodic table. So that's horizontal. Whichever row or period a element is in, that is how many rings, how many electrons you will have, or how many electron rings, energy shells you will have surrounding the nucleus. So we have the nucleus first, we have 17 protons, 35 neutrons, and then chlorine is in row 3, so we have 3 energy levels. And we'll talk about in just a second how many electrons to put on each energy level. One other additional fact that you're going to want to take note of is that the electrons that we put on the last energy level are called valence electrons. And the number of valence electrons you have, the number of electrons you have on the last energy level, is determined by the group or the column that an element is in. We'll get more into valence electrons in the future when we talk about ions, but I just wanted to let you know that right now, that those electrons on that last energy level are called valence electrons. So let's see how we know how many electrons to put around each ring. The row determines the number of electron energy levels. That means, if we take out my nice pen right here, this is row 1. Hydrogen and helium are the only two elements in row 1. Then we have row 2, row 3, etc., etc. And they extend all the way across. So row 2 goes all the way across, row 3 all the way across, row 4 all the way across. And that row number is going to tell you how many energy levels you need to draw. So you'll have your nucleus first, and then you'll draw a certain number of energy levels based on whichever row it's in. So if I had sodium right here, I know I would need 3 energy levels. If I had potassium right here, I know I would need 4 energy levels. If I had cesium down here, I would know I would need 6 energy levels. And so that is how you determine the number of energy levels. The next important thing is how many electrons can actually fit on each energy level. Well, the first energy level around each nucleus can hold 2 electrons. So the highest number of electrons you can put on that first energy level is 2. If we look back at these, chlorine has 1, 2 electrons on its first energy level. Down here, this is calcium, has 1, 2 electrons on its first energy level. You can't ever put more than 2. However, after that, every other energy level holds up to 8. And an important thing that's on here, before you move to the next energy level, you have to fill the preceding energy level, meaning you have to fill up energy level 1 with 2 electrons before you can put any electrons on level 2. Then you have to fill up level 2 before you can put any electrons on level 3. So that's how that goes. You got to fill each one up. And the first one fills up after 2. The rest all fill up after 8. You always want to fill them up first. Already reminded you atomic number. Remember atomic number right here? That's what determines the number of protons and electrons. So that's how you are going to know how many electrons you have to put on an energy level. And the group number up here, so 1, 2, and then 3, like that. That is what determines the valence electrons, how many valence electrons are in the outermost shell. The one thing unique about that is over here these group numbers are like 13, 14. You want to picture this like you forget that the 1 is there, like this is group 3, this is group 4, this is group 5, like that. But we'll get more into valence electrons a little bit later. I want to focus on Bohr models for now. So drawing a Bohr model. You identify the element using the number of protons given. Then you draw the nucleus first. Sorry, that says nuclear, but it's supposed to say nucleus first. And then you label the number of protons and neutrons. Draw the correct number of energy levels based upon its row, and then fill in the correct number of electrons, filling it first, then second, etc. energy levels. So this is actually going to be a different video, the drawing of Bohr models. So check out that video and you'll see how we actually draw them now that you have a general idea of what a Bohr model is. Until next time.